Hello friends, this video on application of derivatives part 9 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 8. Let's take one more example. We have to prove that the function f(x) equal to sin x is strictly increasing on this interval and strictly decreasing on this interval. Also, neither increasing nor decreasing on this interval. So these three things we have to prove. So for proving all these three, we can use the theorem. The first thing we can do is we can find f dash x, correct? Because with this, I can prove that the function is increasing or decreasing. So let's find f dash x. Fx is equal to sin x, then f dash is nothing but cos x. Let's take the part 1 now. Part 1 says that my domain is 0 to pi by 2. If you take my domain 0 to pi by 2, my cos x will be positive always. If you see, I'll take case 1, I'll write here. Case 1. You take cos 0, 1. Cos pi by 2, 0. You take any value of cos from 0 to pi by 2. Because if you see this, all sine, tan, cos, this graph, we know here everything is positive. You take sine, cos, tan, anything from is positive. So 0 to pi by 2, you take any value, the cos is always positive. I can say that my f dash x is greater than 0 for each x where x is member of 0 to pi by 2. If this is true, I can say that the function is strictly increasing. This part is solved. Let's take second case. Strictly decreasing on pi by 2 to pi. So pi by 2 to pi is this range. Here only sine is positive. Cos, tan, all negative. So here in this range cos is negative. So you take any value of f dash x, that is cos x, right? Where x is from pi by 2 to 0. This is always less than 0. For each x where x is from pi by 2 to pi, correct? Vs is open, we are not including pi by 2 and pi, please note that. So if you see here also we are not including pi by 2 and pi, so we should not take 0 actually. We should not take 0 and we should not take pi by 2 because those values we are not including, correct? We should take something cos pi by 4 is positive, cos pi by 6 is positive, all these values are positive. Similarly, in this case, you take any value of x that is in this open interval of pi by 2 and pi, this comes out to be negative because there cos is negative. So my f dash x is less than 0. If my f dash x is less than 0, please note my function is decreasing function. So this guy is true. Now if case 3 is nothing but merge of these two. So if you see case 3, between 0 and pi, I see that from 0 to pi by 2 my function is increasing and pi by 2 to pi my function is decreasing. So my function is neither increasing nor decreasing in this domain where x is from 0 to pi. So this proves that the function is neither increasing nor decreasing in this domain where domain is 0 to pi, correct? So if you see the same function is increasing in some domain, decreasing in some domain and neither increasing nor decreasing. So if you draw the graph also of f dash x, this is something like this, correct? So this guy is my 0 to pi by 2. This guy is from here, this is 0, this is pi by 2 and this guy is pi actually. So if you see from 0 to pi by 2 it is actually increasing. Why increasing? Because this is always greater than 0. This is, please note, this is not the graph of f dash x. This is the graph of this is not the graph of fx. This is the graph of f dash x. So here to here is positive, right? And from here to here negative. If you draw the graph of fx, this is cos x actually, right? If you draw the graph of fx, this sin x, if you see the graph is something like this, sin 0 is 0, like this. So from 0 to pi by 2, it is increasing, and pi by 2 to pi, it is decreasing. Correct? And that's how it is. Let's take one more example of increasing and decreasing function. In this example, we have to find the interval in which this function 2x square minus 3x is strictly increasing and strictly decreasing. The formula, we know that we have to find f dash x. If this guy is greater than 0, this is increasing. If this is less than 0, it is decreasing. Correct? So let's find f dash x. If my fx is equal to 2x square minus 3x, this 2x square minus 3x, my f dash x will be 2 into x square became 2x and 3x became 3. That is 4x minus 3. Correct? Now if this function is increasing, this quantity has to be greater than 0. So I'll say case 1. Case 1, increasing function, that means f dash x is greater than 0, or 4x minus 3 is greater than 0, or I get x is greater than 3 by 4. In this case, my function is strictly increasing. Case 2, strictly decreasing. I'll just say S here. In that case, my f dash x has to be less than 0. In this case, 4x minus 3, that is the value of f dash x, will be less than 0, or x will be less than 3 by 4. If you want to add more conditions here, you can have case 4 also, where it is increasing. In that case, it will be greater than equal to 0. So my x will be greater than equal to 0. And for decreasing, it will be less than equal to 0. So that is f dash x will be less than equal to 0. So my answer will be x is less than equal to 0. Correct? So this is strictly increasing. This is strictly decreasing. And my x is greater than equal to 0, greater than equal to 3 by 4. This will be increasing. And x less than equal to 3 by 4. This is decreasing. Correct? So 4 scenarios. Let's take one more example. Very similar to this, but here it is the equation of power 3. There it was power 2. So here finding the value of x is a little tricky. Here also we have to find the intervals where this function is strictly increasing and strictly decreasing. So we know that a function is strictly increasing if my f dash x is greater than 0, strictly increasing, and if my f dash x is less than 0, it is strictly decreasing. So let me take my case 1. My f dash x will be nothing but, if my fx is 2x cubed minus 3x square minus 36x plus 7, my f dash x will be nothing but 2 into x cubed become 3x square minus 3 into x square became 2x minus 36, x becomes 1 and 7 becomes 0. So this comes out to be 6x square minus 6x minus 36, and that is nothing but 6 into x square minus x minus 6, and this if you factorize, this becomes 6 into x square minus 3x plus 2x minus 6, and that is nothing but 6 into, this will come out to x minus 3 into x plus 2. This is the value of f dash x. So let this be a general f dash x. If you take case 1 now, my f dash x has to be greater than 0 for strictly increasing function. Has to be greater than 0. That means 6 into x minus 3 into x plus 2 has to be greater than 0. If this is true, now we have to find the value of x. This is nothing but inequality equation. So in this case, if you see, the breakpoints are minus 2 because x plus 2 is greater than 0. So minus 2, x minus 3 is equal to 0, so 3. These are the two breakpoints. And how do we solve such an equation? What we can do is we can take any value in either of these range and see if the value is positive or negative. So let's suppose 0 here. Okay, let 0 be a point here. If you put x equal to 0, this comes out to be 6 into 0 minus 3 is minus 3, and 0 plus 2 is plus 2. This is nothing but minus 18 into 2 minus 36. So this any value in this range is negative. This side is positive and this side is positive. That's how we do. If we have this inequality equation, how we solve is we take any value in this range, any range you can take. For example, if you take minus 3 also, you can find, it's fine. You can take any value. So 0 is a simple number, so I took 0. So I got a negative value. So this means you take any value in this range, you get negative. And it's alternate. If this is negative, this has to be positive, and this has to be positive. Correct? This is how we solve this question. So in this case, I can say that my minus 2 comma 3 range is negative values. That is f dash x will be negative. And minus infinity to minus 2 and 3 to infinity is positive value. So I can say that f dash x is equal to greater than 0, or I can say that x is nothing but minus infinity to minus 2 and 3 to infinity. So this is my value for f dash x is greater than 0. Similarly for case 2, my f dash x is less than 0. So less than 0, that means my x is member of minus 2 to 3. And please note, it is all open interval. Why? Because I'm talking about strictly increasing. So it is greater than, it is not greater than equal to. Correct? It is greater than, it is not greater than equal to, or less than, not less than equal to. So it is all open interval. So the question is very simple. Here also we found f dash x, and we have to prove that or we have to find the value of x for which f dash x is greater than 0 and f dash x is less than 0. Since it is an inequality equation, it was a quadratic equation here, and we use this form, this method where we find the breakpoints here. The breakpoint here was minus 3, plus 3 and minus 2. So we have put plus 3 and minus 2 in the number line. We took any number in between, we got negative. So that means you take any value in this domain, you get negative value as an output, and you take, then we know that the range alternates. That means this guy has to be positive and this guy also has to be positive. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.